All right, so we're moving on to the next kind of factoring, and you've heard me say this before. Difference of two squares factoring is my favorite. I think it's the easiest to recognize. I also think it's the easiest to execute. So it's my favorite one. I think it takes the least amount of effort in a lot of ways. I think even GCF can be a little more challenging. All right, but speaking of GCF, I'm going to start with GCF. And so I see x to the 10th and x to the 8th. So x to the 8th is a GCF. So 4x squared, that would multiply back out to 4x to the 10th. So that part's right. Minus 9, that multiplies back out to minus 9x to the 8th. So I'm good. All right. This looks familiar. This is no different than what we were doing in the quadratics chapter. So we're set up and ready to go. X to the 8th needs to be recopied. And remember, since this is a difference because it's a minus sign, perfect squares, 4 is a perfect square and 9 is a perfect square. You know that. X squared is a perfect square. Remember, the rule is that anytime you have a letter to an even exponent, then it is a perfect square. All right, so if it was x squared, x to the 4th, x to the 6th, x to the 8th, x to the 18th, x to the 26th, any of those would be perfect squares. All right, so what am I going to multiply to get 4? Well, 2 times 2, x squared, x times x, and 9, 3 times 3. And remember, the idea is when I FOIL, I'm going to need the middle terms to cancel out. So one's got to be plus and one's got to be minus. You can do minus and plus. You'll see me do plus first. So remember, the idea is when you're checking, you're going to FOIL it back out. So that's 4x squared minus 6x plus 6x minus 9. I've still got that times x to the 8th. The minus and plus positive 6x, those cancel. So now it's 4x squared minus 9. That's going to be 4x to the 10th, and that's going to be minus 9x to the 8th. And sure enough, that equals what you started with. So again, anytime you're factoring, if you want to check your work, multiply it back out, and that'll give you the original answer. If you're doing it right, of course. Our second problem is really easy. We're going to just make 2 changes that I don't want you to get upset about. I just want you to go, it's fine. X to the 6th, that is a higher exponent, but remember, since the exponent, it's a letter to an even exponent, we know it's a perfect square. It's still a difference. 49 and 100 are both perfect squares, so it's still a difference of perfect squares. I also don't want you to get freaked out if you lead with a number. It's fine. Don't change the order. I know that to get 100, I need to say 10 times 10. So it's fine to have your factors lead with a number. It's not as traditional, but it's fine. One's got to be plus and one's got to be minus so that when you do FOIL method, the middle terms cancel each other out. 49 would be 7 and 7. X to the 6th would have to be x to the 3rd times x to the 3rd. These are not perfect squares again. So you're done. Now we have 81x to the 4th minus 16. Again, 81 and 16 are both perfect squares that you know of. X to the 4th has an even exponent. That's a perfect square. This is a difference. There is no GCF. There's nothing that goes into both 81 and 16. So you just start it, and you might think this problem doesn't seem as hard while we're doing this because of what happens on the end. So I know 81 is 9. X to the 4th would be x squared times x squared. 16 would be 4, so I always put the plus 1 first, the minus 1 second, okay? So why'd I do this problem third? Because don't forget, sometimes you've got to go and go again. So this is a sum, so it's not going to go again. But notice this is a difference, and these again are perfect squares. So this guy expands out further. So it goes from an x squared down to 2x to the first polynomials. So 3x squared is going to be 3x plus and then minus, and then 4 is going to be 2 times 2. And the reason my habit is to put the minus one last is because I know the plus one generally won't go again because it can't be a difference of perfect squares if it's got a plus sign in it. The last one might go again, so I like to put the one that might go again on the end. That's just a personal habit. You don't have to do that too. Well, can this go again? No, because it's x to the first, and once you get down to x to the first, you're done. Our fourth example, and we're going to do 5 this time too. Our fourth example has me starting out going, wait a minute, this is difference of 2 squares, but these are 150 and 24, those aren't even perfect squares. Don't forget, it's always GCF first. So can I think of a number that goes into both 150 and 24? Well, you know what I'm doing? I'm kind of going backward about it. What perfect square goes into 24? 4. How many times does it go in? 6. So my question is, if this is 4 times 6, is this another perfect square times 6? Well, sure enough, 6 does go into both of these. So I'm kind of going in through the back door on that GCF. And I notice with x to the 9th and x to the 1st, I better pull the x to the 1st to the front. But it's 6 times 25, which is your other perfect square, x to the 8th. That's a perfect square because x to the 8th has an even exponent. And then minus 4. So double check, that's 150, x to the 9th, check. That's negative 24x, check. So you're good. These are both perfect squares, so go again. So 25x to the 8th is going to be 5x to the 4th times 5x to the 4th. 4 is going to be 2 times 2. One's a plus and one's a minus. That's a sum. It's not going to go again, period. That's a difference. It will go again if these are perfect squares, but 2 and 5, they're not perfect squares. So you're done. One more. All right, I hope you're going to feel a little wild and crazy on this last one because it's going to go and go and go. So I've saved our Energizer Bunny problem for the last one. So I look at it, and again, predictably, 16 and 1 are perfect squares. I've got a difference. X to the 16th has an even exponent. It's a perfect square. So I know 16 is 4 times 4. 1 is 1 times 1. One's got to be plus. One's got to be minus. With the x to the 16th, rookie error, people will think x to the 4th, x to the 4th. But guys, remember, 4x to the 4th times 4x to the 4th is 16x to the 8th. You add the exponent, so that's not right. So if you want to take the square roots, you've just got to remember to half the exponents. So it's supposed to be 8 here. Sometimes people, they know it on the other problems, but when they see an exponent that happens to be a perfect square, they misfire. So, you know, just be careful. Now, this is a sum, so you're done with this part. This is, again, a perfect square. So the square root of 4 is 2. The square root of x to the 8th is x to the 4th. The square root of 1 is 1. So plus 1 minus 1. Well, that didn't go very far because that's a sum. You're not going again there. That you can't go again because 2 is not a perfect square. If it was 1x to the 4th minus 1, I could go again, but it's not. So that one didn't last as long as I thought it would. Now, do the next section on the My Math Lab. And I think the next section, if I'm remembering, is like problems 11 through 17, if I remember correctly.